Hello everyone, you're welcome to my channel. I'm GLYCOLYSIS and we will be exploring on the topic called glycolysis. At the end of this class, you should be able to define glycolysis, know the phases of glycolysis, know where it takes place, know the steps involved. Also, you should be able to know how to draw the pathway very well. And finally, at the end of this class, you should be able to calculate the total number of ATP produced in glycolysis. Okay? Before I start the class, do well to share, like, and subscribe to our channel. Okay? Glycolysis is a metabolic pathway that converts glucose, which is the primary energy for the cell, into two molecules of a three-carbon molecule called pyruvate. It takes place in the cytosol of the cytoplasm and it has 10 steps. So we have phases of glycolysis. So we have the preparatory phase. Preparatory phase that comprises rather of the priming phase or stage and the splitting stage. We also have the payoff phase. Payoff phase. We have 5 steps here. These 5 steps, making it 10 steps. So why is it called the priming phase? It's called the priming phase because energy is invested in form of ATP for subsequent breakdown of the glucose molecule. So another name for the priming phase is the investment phase. So we can call it priming phase or investment phase. And the priming phase runs from glucose down to fructose 1,6-bisphosphate. We are going to be drawing the pathway very soon, so you'll see. So it runs from glucose to fructose 1,6-bisphosphate. The splitting phase runs from fructose 1,6-bisphosphate to 2 molecules of glyceraldehyde 3-phosphate. Then the payoff phase runs from 2 molecules of glyceraldehyde 3-phosphate to 2 molecules of pyruvate. So we are going to be drawing the pathway now. Stay tuned. Oh. So we have from glucose a hexose monosaccharide. Glucose is converted to glucose 6-phosphate. By an enzyme called hexokinase. So where is the phosphate coming from? 1 molecule of ATP enters. ATP is adenosine triphosphate. So this kinase enzyme transfers 1 molecule of phosphate, gives to glucose. Glucose is converted to glucose 6-phosphate. Then the ATP is reduced to ADP, adenosine diphosphate. This is the first step of glycolysis, the first step of the priming phase. So in the second step, glucose 6-phosphate is reversibly converted to fructose 6-phosphate. And the enzyme that facilitates this reaction is phosphohexose isomerase. In the third step, fructose 6-phosphate is converted to fructose 1,6-bisphosphate, and the enzyme is phosphofructokinase 1. We call it PFK1. So this is the priming phase of glycolysis that runs from glucose to fructose 1,6-bisphosphate. Also, ATP is invested here and converted to what? ADP. So 2 molecules of ATP is invested in the priming phase. So now, in the splitting phase, fructose 1,6-bisphosphate is converted to 2-triosis, 2-phosphotriosis. So we have something like this. So we have glyceraldehyde, 3-phosphate. So this is G3P. And also is converted to dihydroxyacetone, phosphate, DHAP. This DHAP is reversibly converted to G3P by triose phosphoisomerase. And the enzyme that facilitates this reaction is an aldolase enzyme. We call it aldolase A. So you now see this is converted to this. We have step 1, step 2, step 3, step 4, and step 5. So this is converted to this, and this is also converted to this. So this dihydroxyacetone and glyceraldehyde are the 2 trioses that we have. So trioses are sugars that contain 3 carbon atoms. So you now see the isomerase enzyme converting DHAP to what? G3P. So what next? We have 2 molecules of G3P produced because this is converted to this, 1 molecule. This is also converted to this, 2 molecules. So everything that is going to be happening in the payoff phase will occur twice. So this is the preparatory phase of glycolysis. The splitting stage is step 1 to step 3. The priming phase is step 1 to step 3, while the splitting phase runs from step 4 to step 5. Now step 6, which is the beginning of the payoff phase. G3P is converted to 1,3-bisphosphoglycerate. And the enzyme that facilitates this reaction is G3P dehydrogenase. And this enzyme works with a coenzyme called NAD+, oxidized nicotinamide adenine dinucleotide. And this NAD+ is converted to the reduced form, NADH. Remember, everything here happens what? Twice. Everything here happens twice. So 2 molecules of 1,3-bisphosphoglycerate. Also, this is step 6. Step 7, 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate. glycerate. So what happened to one of the phosphates? ADP produced in step 1 comes, takes one of the phosphates and is converted to what? ATP. So in the preparatory phase, ATP is used up. While in the payoff phase, ATP is being produced. So we have 2 molecules of 3-phosphoglycerate produced. Step 8 is a conversion from 3-phosphoglycerate to 2-phosphoglycerate. Don't forget to put these 2 molecules. Everything here is happening twice. So, and the enzyme that does this is a mutase enzyme. The enzyme that facilitates this is phosphoglycerate kinase. Mutase. And the name of the mutase is what? Phosphoglycerate mutase. Step 8. And step 9. Step 9. These 2-phosphoglycerate is converted to what? Phosphoenolpyruvate. This step 9. And the enzyme that does this is enolase. So we have removal of water. So water is being removed. So phosphoenolpyruvate is now converted to pyruvate. Remember, don't forget your 2 molecules, 2 molecules, 2 molecules, pyruvate. And the enzyme that does this is what? PK, pyruvate kinase. Now you can see, look at this step 10. You can see the preparatory phase runs from step 1 to step 5. Step 5. While the payoff phase runs from step 6 to step 10. In our next video, we'll be talking about the fate of this pyruvate, what happens to this pyruvate. But now, we need to talk about the number of ATP produced from this pathway. As you can see, 1 ATP is being used up here. Before we do that, I need us to understand that we have 3 irreversible steps in this pathway. Step 1, step 3, and step 10. And those 3 irreversible steps are the regulatory steps of glycolysis. We'll be talking about how to regulate the pathway maybe in our next video. But for now, let's calculate the total number of energy produced from the entire pathway. As you can see, step 1 and step 3, ATP is being used up. ATP are being used up. So we have energy, total energy yield. So we can also call it bioenergetics of glycolysis. Bioenergetics of glycolysis. So we have that at step 1, 1 ATP is being used up. At step 3, 1 ATP is being used up. Now, remember, everything at the payoff phase happens twice. So, as you can see in step 6, NADH is produced. And NADH is equivalent to approximately 3 ATP in the electron transport chain. We'll be talking about that. So as step 6, we have 2 NADH now, because everything here is happening twice. 2 NADH, which is equivalent to 2 times 3 ATP, which is 6 ATP. Step 7. Step 7, you can see 1 ATP is produced there times 2, which is what? 2 ATP. Also in step 10, we have, step 10, there is 1 ATP because we have phosphoenol pyruvate being converted to pyruvate. Where is the phosphate? The second ADP here comes, collects the phosphate, and is converted to ATP. So we have 2 molecules of what? ATP. In total, we have -1. Calculate it very well, you 8 ATP. So 8 ATP is produced from this pathway. So in the conversion of glucose to 2 molecules of pyruvate in the glycolytic pathway produces what? 8 energy in form of what? ATP. Thank you for watching this video. Do well. Don't forget to like, subscribe, and share. Thank you so much.